In a world programmed in questions, yearning for answers, we meet today to speak of math that builds intelligence. We try to push common logic, forget time, and simply converse in the simpler attempt at trying to seek those answers. I'm Bhavidhir V. Bhardwaj. Welcome to episode 42 of Genesis of Tomorrow. The following is a conversation about the quantum diaspora, research, learning, success, the current happenings, and much more with Mr. Karthiganesh Durai, a veteran in the field of quantum AI and quantum technology at large. Also, folks, if you're interested in such deep science and deep tech conversations and are able to derive even the slightest bit of value from the show, please support us by clicking the subscribe button so that we can keep improving the quality of the episodes and keep on bringing such wonderful guests over for you. And now, without any further ado, let's get right into it. Enjoy and thank you. And so we are rolling now. Formally welcome to the podcast, KG. Uh, you know, you are a quantum computing architect, and
Correct.
that entails an experience in designing and developing quantum computing solutions with
Correct.
hands on expertise, right?
Yes.
But umpteen times in regard to a technology like quantum computing, it is important to define what solutions explicitly are we talking about. So, could you just give a brief explanation or a detailed one at that, either, uh, in terms of what do these solutions actually mean right now, currently in the industry?
So there are certain class of solutions or problem statements which cannot be solved by classical systems in a polynomial time mathematically. So if you in a layman term, I can tell that in a reasonable time frame it will not be executed. For example, breaking RSA key, because that needs uh, non-deterministic polynomial time, meaning that the time taken to find the factor of a prime number will grow exponentially as the number size increases. That is one problem. If you take AI and ML, there are many problems in AIML which will grow exponentially when we increase the input size. And there are some problem in computational chemistry, the energy level, predicting or estimating energy level, those all those things will grow exponentially when we increase the sample size. And there are some problem in industry, like portfolio optimization, scheduling. These kind of problems also will increase exponentially, and these problems generally classified as NP hard problems, non-deterministic polynomial time hard problems, are suitable for quantum computing approach. And there is one more class of problems which need accurate input, like weather forecasting. So the property of nature, they are not binary number. We are approximating a real number or complex numbers into binary numbers such that they will be processed using digital computers. So in the process we are losing some accuracy. So the weather forecasting type of problem needs data without so these are the class of problems which are solved by quantum computer. And these are a lengthy list, right? If you need in summary mathematically, I can tell most of the um, ordinary differential equation, partial differential equation of higher order. So higher order ordinary differential equation, higher order partial differential equations are suitable use cases for quantum computing.
Having said that, what makes quantum computation unable to actually solve these NP hard problems, because it's a very fundamental concept, right? Anybody who studies, who's got a background in computer science, they go through this phase where they have to learn, data structures and algorithms. And one of the key aspect of the entire thing is, how do you cater to the space and time complexity problems? And the greatest sort of challenge or the pain point to students is catering to those NP hard problems. What sets quantum computation apart to a degree that it's exponentially more efficient at catering to these problems than classical methods? What are the list of those particular properties?
The first reason is that quantum computing is natively parallel processing capability. So when I say natively parallel processing, you may ask question, digital computer also having parallel processing, multi-threading, but they are not natively parallel. How are we doing? We are using multiple processors and divide the work into them, then they are doing parallel, then we are combining. So mathematically they are sequential operation only, but we are using infrastructure to map and reduce those problems. Whereas quantum computing is enabled by superposition and entanglement. So the superposition is one property which gives natively parallel processing capability. So now you may have a question. Oh my god. Now you may have a question. How come superposition enables parallel processing? If you take the equation for superposition, psi ket equal to alpha 0 ket plus beta 1 ket. Here alpha and beta are probability amplitudes. So because of this probability amplitudes, we are having both 0 and 1 at the same time with a certain probability. Between 0 some probability to 1 ket, and the sum of probability equal to 1 because of the normalization. Now if we increase the number of qubits, it will become, for example, if I have 3 qubits, I will have 8 possible states at the same time. Psi alpha 1, instead of alpha beta I am putting alpha 1, alpha 2, alpha 3, alpha 8. So there are 8 probabilities for 8 states at the same time. And if I increase that n to the 3 to some other n, say 10, I will have 2 power n states at the same time. So this one particular behavior gives natively parallel processing capability to quantum computers. That is the reason why quantum computers are exponentially faster for certain class of problems.
That is said for what we understand about how they compute data. But for the system, for the computational system, do we know anything about how that particular quantum system may perceive data differently than the classical system? Because we know that the quantum system is processing information, right? In a different manner than the classical system, surely done. But does it do maybe more than merely computing? That is in an essence experiences those patterns differently than classical computing? Do we know anything in that
Yes,
regard?
yes, entirely different. The reason is that classical systems are using 0 and 1 binary numbers, whereas quantum computers are using complex numbers, a vector. The 0 ket, 1 ket, these are all vectors and they are complex numbers. So fundamentally, the input to any quantum algorithm is complex number, it is not a binary number. So this is one fundamental difference from the data perspective. And the operation also linear algebra, not Boolean algebra. When I say linear algebra, it is vector operation and matrix operations. So the states are represented as vector, they are transformed using matrix. So when I say matrix, matrix has lot of capabilities. from starting from composition, decomposition, matrix multiplication, all these operations have the capability of transforming the quantum states in a natively parallel fashion. That is one reason, the fundamental difference in the data input.
As for, okay, there are, we know that in the past few years, quantum technology has come out of the academic and theoretical bubble into the industry, different branches of it. In terms of what is demanded from a quantum computing engineer or researcher or any industry, any particular industry role, what currently are the demands for these people who are needed to, who need to be working in the industry side of things in quantum technology, and how can the young folks who are in college, just completing their undergrad or something, they can prepare themselves to cater better to those demands of that particular role?
So here I would like to address the realistic and practical goals. First reality is, to build any industry solution we need minimum 40,000 qubits. 1 lakh qubit are ideal for solving many problems. But as of 2025, we are able to achieve 1121 qubit from the IBM system and 1180 from neutral atom computing, neutral atom based quantum computers. 5000 qubits for quantum annealing. So the minimum required number of gates or qubits is not achieved by the quantum computing technology yet. That is the reality. So the young folks, researchers, students who wants to pursue quantum computing as a career, they have to understand this reality. So whatever we are doing as of now, 2025, it is all proof of concept, prototyping, then futuristic solution approach only. So the real industry adoption is going to come from 2028 onwards. Till the time we cannot build any industry solution using quantum computer. That is the first realistic understanding or the reality check. To answer your question, how the young folk can get ready, understanding this reality, what they can plan, how the industry, both scientific and engineering community particularly, going to adopt quantum computing starting from 2031 or 2028. What will be the level of adoption by the industry? That we should have a clear picture. And the domain knowledge, it is very very important, because if you take the AIML's problem, the AIML problem which can be solved by quantum computers are not just a simple Python import. Pip install is not sufficient. They have to understand the deepest problem in the domain. For example, if you are trying to solve PCA, principal component analysis, or any neural network, we have to understand how the classical data is encoded into quantum. When I say data encoding, I am talking about binary to complex numbers. Whether we are loading our data into an angle or into amplitude or into both, or just we are using basis encoding, meaning that 000 is encoded into 000 ket. So that understanding is very very important with respect to the domain. That is where the important gap starts, and then it is increasing. Many software engineers or data scientists who are jumping into quantum, they are simply assuming that it is a Python. No, it is not programming language. It is the underlying mathematical model. It is a kind of paradigm shift. The mathematical model is no longer binary. It is a density matrix of complex numbers. We should be able to visualize the density matrix and how a regression line in classical world, which is linear, is transformed into a non-linear regression line or non-linear hyperplane in the quantum computing world. So this is an important aspect they have to understand. After that, they have to apply, then they can build a solution. If they are building now, it is a futuristic solution. And when they try to benchmark it, certainly it will not outperform state of the art classical approach. So that they have to realize. So if they are able to build an algorithm which provisionally provide a solution for classical counterpart, they are good. But they should have a prediction how this algorithm is going to perform when we are adding 4000 qubit, 10,000 qubit, 12,000 qubit, 40,000 qubit. Yeah, that is the important understanding for those who are jumping into quantum computing.
I think that is the most potent point here again. From most people who I know who are venturing out into quantum computing for the first time, there is a common mistake that they often do, which I even committed, which was you come from a mindset of okay, this is a programming language. You jump onto Qiskit, you read the documentation, and you're like you're encoding gates, and you're like okay, I understand it. But the frame of mind that is required is much more of a researcher than a developer in this particular domain that I have observed. You have to be coming from that particular
Exactly.
frame of mind where you are not only thinking about I have to program stuff, but you are actively thinking about how do I make the math work here, and then how do I make sure that the physics doesn't fall apart while I'm programming the stuff. I'll give an example
Exactly.
about the project part that you mentioned. You know, for most engineering students or even science folks, they are told that to build a good portfolio or resume, you should work on building projects. One thing that
Correct.
anybody would realize when they go on about trying to build a quantum project is that how vastly different it is from your normal computational projects, AIML projects, or data science projects. So, building a quantum project end to end is vastly different from building a normal AIML or classical computational project, in the sense that while you're building a quantum project, there are umpteen different aspects of it where you yourself would have no idea of how it works. And therefore, you'll have to dive into the theoretical foundations. I was building a quantum hash function, right? And I did not know anything about cryptography. I tried to search different projects that I can build. I came across build a quantum hash function. Sounded fancy. I was like, okay, let's try to build it. And you are through with the coding part. From the Qiskit documentation, from different resources, using generative AI a little bit here and there. And you're like, okay, wow, I got this thing working. But that won't be an end-to-end project. It won't be a complete project. Why? Because you did not think about the different tests. How does it perform in bitwise operations? How does it perform on collision testing or avalanche testing or different other aspects of it? So that is a personal anecdote that I experienced. You tell me, because you are working in this domain. When you're building a particular project, working on a particular project with a team or otherwise, is it something that you also experience after so many years in the industry?
Fortunately, I had that clarity uh, even before the industry start working on it. I will tell you the reason. In 2010, when I was doing my master's project for my MCA project, I worked in implementation of quantum computing algorithms using QCL. The QCL is a simulator. That was a language most of the people don't know who entered the industry now. But at that time, 2010, it is was from Austria. Umar is the his PhD thesis was this project. So when I started working on that one, I also started thinking that it is C++ syntax, so I can apply that one. But when I try to implement the Dijosa algorithm, I realized that this Dijosa algorithm, even though it is tell it is the constant or balanced Boolean function, there is no way to convert my digital circuit into a quantum circuit. So then what are we trying to solve? I realized Dijkstra algorithm, there is no any practical application. But everyone start with the Dijkstra algorithm, but there is no practical application. Why? Because translating your digital function or your Boolean function into a quantum circuit is very difficult. So that reality strike me well in advance. And that time I get help from my mentor. Then I realized, and at the time most of my mentors are mathematician, not software engineers, because I the only software engineer. So they explained me mathematically how it is not the usual classical programming. I'm fortunate enough to learn quantum computing from mathematicians than computer professional. That is one reason why I got that clarity at my first attempt.
Right. I'll ping you a little more further in the same direction. Uh, how then folks who are starting out, who are relatively new to understanding how things are working in this particular subject matter, how can they build proof of work or proof of skill? Because if you want to land an ML job, uh, it's pretty the roadmap. There are umpteen roadmaps that are already available. Okay, build so and so project that has so and so checklist that hits so and so checklists, and you're good to go. But for for getting into the quantum industry, what is the sort of proof of work that a student or a young professional can work on to show their competence in the domain?
First point, they have to realize it is pure interdisciplinary. They should not try to solve the problem by themselves. Since they know Python programming, it is not entitling them to build quantum solutions. They need to identify the team of three people. One is domain expert, next one is physicist, third one is mathematician. And this poor guy should be a developer. You got the point, right? So now, how a student can identify these four people or three people? A student don't have that luxury of connecting with the domain expert, physicist, a master in physicist, a master in mathematician. They can't find it. So, what they can do when they select the problem of statement, obviously they will come to know it is not their domain. It may be electrical domain or mechanical domain or chemistry domain or cryptography or communication or finance or economics. These are all the problems. A software engineer obviously will not have this domain knowledge. So the first point, he or she should identify this is our domain. For this domain, connect with a professor or a industry person who is facing the problem. Then the physicist mathematician, this software engineer can learn himself or herself, or else if they have the luxury of these professionals in their network, in their college, maybe in college engineering students never go to humanities department. That is where physics and mathematics are there. So they have to go to humanities department, connect with the physics professor and the mathematics professor. then get their help. Trying to build something, can you help me? After connecting these three people and understanding the mathematical model for the problem, then this developer or this student can start building the solution. It is not only from the beginning. Even if you reach the highest level of industry position, still you need interdisciplinary people. That is one thing we have to realize. Even though there is the word quantum computing, it is not pure computer science or information technology. It is interdisciplinary. Why we need domain people? In the domain, we are trying to solve the research level problems that normal industry people or normal domain people cannot answer. For example, there is a feature and option price estimation. If you ask this problem to a normal finance guy, he will tell, yeah, there is system used it. But the research level finance researcher know very well, simply applying Black-Scholes method will not solve. Monte Carlo simulation is not going to solve. They need a pure parallel system. The researchers only know the pain in solving the feature and option prediction. They only can help this programmer. Identifying the domain people who have the research level knowledge in the industry problem is the key step here.
So, sort of to again confirm, if you want to build a project in the quantum domain, you need it's first is the understanding of it needs to be an interdisciplinary subject matter that you have to have that sort of reference in your mind. Second, you need to reach out to the domain expert, the physicist, and the mathematician to understand how these different cogs of your project will be working. You identify, fortunately, you are able to identify a problem gap or your problem statement, and then you work on that particular problem statement from the collective perspective of all these three, four people to try to
Exactly.
derive an interdisciplinary solution.
Exactly.
See, that is so very different from how anybody would, approach a normal building a normal project, which is you find some GitHub repository or some articles for reference. You try to gather materials, maybe watch a YouTube video or two, and then you just start working on it. It's so vastly different from it.
Here we go. Yes.
Yes, and okay. Another interesting thing, as an employer, then what exactly are you looking for in a person who reaches out to you? And
Okay.
also a second part of the question: is it possible to get into the quantum industry, get a position in the quantum industry straight out of your undergrad? Because there are again discussions about it, that do you need a master's or a PhD to first uh, gather that core competence in the domain if you want to get into quantum industry? Like, how does that work?
Yeah. This is a very opt question, I will tell you. Just now I explained it is a interdisciplinary, we need four people. Then it may be intimidating for any entry level freshers, undergrad. An undergrad who is trying to enter quantum computing, they will be overwhelmed by the level of knowledge expected. Am I right? So here the reality is, for example, as an employer, take my way of hiring intern or my team member. For any project, I need domain expert, physicist and mathematician and developer. So already I have recruited two physicists, a master's in physics and who is doing PhD. One researcher is applied physicist, another one is a theoretical physicist. So two physicists I have, and one mechanical engineer. Why mechanical engineer? Mechanical engineer are good at domain, understanding the domain and mathematics also. So I personally experienced, mechanical engineers are much problem oriented people. They can easily understand the problem even in other domain. After hiring these two people, already I have these three members in my team. Now if I'm building a solution, I need one software engineer who is going to build either the web application or a desktop application with the API interface, which is calling the IBM Qiskit uh, call, then show me the output. So for this one, the intern no need not to be a quantum expert. If the person just knows Python, Django, React, or TK Inter, or whatever software framework I am going to use for my solution, that is enough. So this person is lucky because he or she is going to join a team who already have that domain expertise, physicist and mathematician. So when a person joins our team, a software engineer, an undergrad software engineer joins our team, they are not going to face any issue because being an architect, I will divide the problem, give exactly the software component to this person. So identifying this kind of organization who have the necessary resources, skill set already in the team, for them it is easy. If there is no such a team exist and the undergrad is going to play all role, that is where challenge comes. I'm not telling it is not possible. It is possible, provided there should be some mentor who is going to guide the undergrad. You have to acquire this knowledge in this order. That is very, very important because they should not straight away jump into quantum mechanics. They should refresh their knowledge on complex number, linear algebra, set, group, field, vector space, Hilbert space. After refreshing these knowledges, they have to connect with quantum mechanics, superposition, entanglement, interference, and how these mathematical operations are represented and manipulated. So maybe for a undergrad who thinks about okay, we can just go to GitHub, import it, git clone, solve the problem. For that mindset it is very difficult because here they can't clone it. They have to sit down, write it down, think through it. There are a lot of thought process. It is thinking task. It is not writing or coding task. It is a thinking task. So quantum computing solutions are mostly built on your brain, not in the computer. So a person should ready to build the solution in their mind first. Yeah, this is the suggestion. If any undergrad try to enter, they have to know very clearly it is interdisciplinary. The team already exists. Our work is just software interface. They are saved. They can directly focus on it. But they are going to join a team. There are no any expert. They are the only person going to build the solution. They have to ready to start learning maths and physics. I won't recommend domain. Domain is not at all possible. Don't try to learn domain. Always domain we should get from the domain expert, subject matter expert. But these three skills we can acquire.
Turning the question on its head, how do you approach? Okay, I do think it'll be a little bit of an extension to the project sort of question that I asked you before. But how do you cater to a problem statement and everything while you approach this entire process from a perspective of an entrepreneur? Let's say you want to
Oh,
start a venture in the quantum domain, and you see that there's hype around it, there's a boom in the investor circle and the venture capitalists. They are ready to pay quantum startups and everything. You're like, okay, I'll start one myself. And we already discussed that you need these four people in your team. You need, how do you get them? What do you look out in these four people? What, how do you designate the work and everything? How do you search for a problem statement? How do you do everything? But After having established that base layer, how then do you go on about to take this quantum project and turn it into a full-fledged business?
Okay, so here I would like to start with the ethical point, because in 2025 it is very easy to get a VC or AA, angel investor or venture capital. It is very easy compared to our old days. When I started my first business in 96, I cannot think about venture capital or AA, not at all possible. But now it is very easy. I'm being approached weekly, two or three when VCs ready to fund my business. But I used to tell them no. I decided to bootstrap for 2 years. So 2 years I want to bootstrap. I don't need any external money. With my own money, if I'm able to turn things around and I'm able to establish a process, then I will confidently go for funding. That is the ethical thought process an entrepreneur should get, not only for quantum, for any business. So now you may ask a question, KG, that is very long. Two years, it's very huge for an entrepreneur. They can't waste 2 years by bootstrapping. Here I'm telling you, it's not wasting. That is the crucial period where they are learning the important aspect of successful business. If you withstand a business for generation to generation, not just going for funding, getting funding for this quarter and another 3 quarter or 4 quarter, oh I'm not able to build a solution, or funding is not sufficient, I need more funding. No, I'm not telling that way. I'm telling a business model which you are establishing now. Your next generation is able to sustain the business. If you think about that kind of longevity for your business, it should have a solid foundation without any external support. It should be self reliant. How that self reliance comes? When there is no any funding and the revenue is generated from your own business operations. If you are able to establish that cash flow just to sustain, don't think about earning more money, buying a car or buying a house. That is not the goal. You are building a process which can sustain generation after generation. That is the first point. Is it clear? Now coming to quantum, as I told you, the hardware or the infrastructure of quantum is not ready for real life problem. Industry is ready to pay only for solutions which they can use in their day to day operations. Only very few organizations are ready to invest on a R&D which they can use it after 5 years. But those organizations, those Fortune 500 companies, they are not ready to consider startup. They will go for established another Fortune 500 company only. Am I making sense?
Yes.
So when an entrepreneur who started a business just because of B school or technical higher education undergrad, they think that okay, I have an idea, I have some idea, I can get. No, that is not always going to sustain. Before finding a venture capital or angel investor, you have to talk to your customer. If you are not able to find the customer, talking to VA and VC and AI, no use. And if the customer promise you, okay, so Mr. So and so, you come up with solution, I ready to give fund or order. For that, I need three developers or three resources, I can't pay them. Now I can go to VC or AI telling that I secured an order from this customer, but to execute I need money. That should be the right flow for an entrepreneur. And when it comes to more specific to quantum computing or quantum technology as of now, before contacting any customer, this entrepreneur and his team should have published a minimum 5 papers, research papers. That is very, very important, because for other business, if you go to customer, the customer is going to ask, what is the proof of your work? You can tell your profile will have lot of portfolio. Your portfolio will include lot of projects. You can show them. But in quantum, you cannot show. There is no portfolio. Then what is your portfolio? Your portfolio is proof of your knowledge on the specific topic. If you have published a paper on quantum inspired algorithm, quantum machine learning, quantum optimization, quantum metrology, quantum sensing, or anything, some papers, you and your organization, then you can contact your customer confidently. Hey, my team published these papers. This is our area of expertise, and we can try to solve your problem. So these are the three aspects. One is ethical point, try to bootstrap 2 years. Second one is understand the reality, approach the customer, then approach a VCR AI. Third one is have research paper in your profile.
Hmm. And yes, there it's important to know that it is better in the long run if you do not go after taking shortcuts. Like umpteen times with papers, something that you'll agree is a common denomination is that there are these different journals that publish you if you pay them some amount of money. It does not help. It's very easy
Won't
to
work.
identify if the paper or the quality of a research is up to par or not. And it's always better you put in 2 years extra in that particular R&D process rather than doing the mistake of hastening the entire stepwise operation just to build that flashy publication of yours. It's not
That
recommended.
is useful for academy,
Hmm.
not for industry. Industry people, the moment they see the paper, they come to know this. We can use this person knowledge. See, the same way, right? There is a doctor, MBBS doctor, and you know how he or she studied. And when you have an ailment, will you confidently go to that MBBS doctor? You will go confident if you know very well that person really put forth lot of efforts. And if you know that that person just got certificate, you won't go to them. So the same way, because the industry is coming to you to solve a problem, and they should be confident, yes, this person has that sufficient knowledge. To
Uh,
gain that trust and confidence, you should work hard.
Certainly, certainly. And even it'll do more harm than good to yourself as well. Sometimes things are that you do it, you take a shortcut, and it's a neutral thing. You do not gain anything, but you are also not losing anything. But in this case, as an MBBS doctor, if you fake your degree through, if you fake the process through, you'll get banned. Your career will be destroyed. Same thing comes here. You try to forge a
Exactly.
lot of things, one day it is going to come and bite you on the back.
Exactly. At no, it is very soon. In compared to other industry, in quantum, it will bite you in 2 weeks, because the moment you are
Right.
put into a client meeting and they are telling some problem, and you are not using the correct jargon, you are out.
I'm also compelled to ask you about the AI aspect of things in regard to the quantum stuff. Before that, to sort of get an idea about this particular layer or facet of the domain, what does it mean to actually understand something from the point of view of the an artificial intelligence, an AI system, right? If an AI predicts outcomes of a normal data set, or even in relation to a quantum system, is it understanding it, or is it merely making computations? Like, okay, you have an algorithm, you're running it, and you're giving a particular, then obviously output. But in regard to, from a research point of view, is there any aspect of cognition that we have been able to achieve in terms of AI, and how does that equation or dynamic change or stays the same when we bring about the entire matter of quantum AI?
Okay. First, let me clarify the cognitive process of intelligence. The As of now, if the cognitive process of your intelligence and my intelligence and human intelligence, even take any organic, any animal, you just take slime. You take a slime, right? The slime which has single, that organic matter intelligence is cognitive process. And as of now, no one knows what is the mathematical object behind this cognitive process. But when you build something on the machine, whether it is classical or quantum or any computing model, we need a foundational mathematical object. So that is the main gap between machine intelligence and, um, or any organic intelligence. I'm not telling human intelligence, organic intelligence, because I want to be inclusive of all intelligence, not just a human. So when you think about that mathematical model which is powering the cognitive process of organic intelligence, no one knows, but binary is not at all close to this. That is, I am very sure. So we don't have binary. What is the next one? Integer, real, or any numbers, and they are also very difficult to process. So I can take complex numbers or more closer. See, in complex number, we know it is also called binarian. Right? Complex number are also called binarian. And if we expand a plus ib, a plus ib plus jc to imaginary numbers, then I can build what is called, binarian. Then there is a fourth thing. Then if I add a plus ib plus jc plus kd, three binary numbers, I will have octonian. Binarian, quadranian, octonian. This
Optonian,
is
yes.
what mathematicians so far designed. Maybe these things can come closer to the mathematical object behind the cognitive process of organic intelligence. Since the industries or the computing industry matured enough with the complex number by using quantum, we can take this as our base discussion. A complex number representing the property of nature and linear algebra operating this one. Now try to map this capability to the cognitive process. Then you may get a right direction to achieve quantum artificial intelligence. Hope that answered your question.
That is exactly, then,
Partial answer.
no, no, it was a good answer. What was going on in my head is that that is exactly what, in the sort of biological research side of things, uh, when you think about intelligence or cognition, or how the neurochemistry of the brain works, we understand the, again, biochemistry aspects of it. Very recently, research has been started, study has been started in trying to understand the physics, the physical aspect of it, where things are about quantum biology and so on and so forth are in their nascent stages. But as you said, trying to understand the mathematical, or trying to translate all this biochemistry going on into a mathematical formulation that is able to represent all of it that is going on inside our head, is something that we are not even close to deciphering.
True,
Like it's like
true.
it won't be far-fetched to say that it is something that, how there is a basic model at least of multiple different subject matters, subject domains, for a mathematical formulation of how the mind works, we do not have a standard model even to explain how it all works. Like, can we explain the biochemistry of brain in dimensional spaces? How we are able to, because we are trying to find the quantum correlation that implies that we should be able to do that. Can we do that? We cannot, to no degree. And that is why it's, again, tell me about this. You might have heard this a lot, how quantum AI is the next big thing, and so on and so forth, the hype aspect around it. How
Okay,
far do you think? Yes, 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 yes.
here I would like to tell some history,
Hmm.
because uh, my first introduction to quantum computers happened in January 2004, exactly 20 years ago. And it is a kind of first love in first sight. The moment I heard about quantum computing, I decided I want to become a quantum computing professional. At the time, it is only for PhDs, not for undergrad. And I am the only breadwinner. I cannot quit my software job and then go to research. So I decided to learn for 20 years. Then I decided to learn on my own. Whenever I'm, whatever chances comes, I started learning, right? At that time, quantum artificial intelligence is not at all in the picture. At that time, it was only optimization and simulation. Quantum computers were identified as a good computing devices for optimization problems and simulate subatomic scale behaviors like materials and very large system simulation. Like that only they have been identified. But suddenly 2014 and 15, I heard that quantum machine learning is the next big thing. Quantum artificial intelligence is the next big thing. Even without knowing that that is going to come, changed my career from software engineering to data science in 2011. Now you see the pleasant surprise when I see, I decided but I don't know where I will land. And the software career pushed me to data scientist. I became a data scientist. In the middle of the data science career, I'm hearing there is a something called quantum machine learning and quantum artificial intelligence. Oh my god, without knowing, already we are in the right direction. It became logical progress for me. See, now industry is able to accept me because I'm a data scientist. After that only they will see my what are my other background. So so I am the one person who career wise benefited from the quantum artificial intelligence and quantum machine learning. That's why I told this history. Fortunately, for many software professionals, data science is something what they are experiencing now. It is easy for them to move. Correct. Now I will tell the my take on quantum AI and quantum machine learning. Here I would like to call out one movie. You know the Transcendence, the movie called Transcendence, Johnny Depp starrer.
Yes, 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 yes.
Yeah, it is science fiction, may not be suitable for industry or a research oriented discussion, but for a layman, because whoever watches this podcast, it may connect. In that movie you will come to see a photonic quantum computer built by the Johnny Depp conscious. It is helping to improve the machine learning model running on the system. Then that quantum machine learning models are again improving the photonic quantum computer. But that is what the movie talks about. A quantum computer building the AI model AI model improving the quantum computer. That is how that continuous process improvement, then the system started outperforming its own previous execution. So this is one fictional example. Now I will take a real life example. You know the company called Classic,
Yes, yes, yes.
CLASSIQ. That Classic, they are using quantum machine learning model to optimize quantum circuits. Yeah, that is one of their stronghold. Their QML models have the capability to optimize the quantum circuits. Why we have to optimize the quantum circuits? When the quantum circuit starts execution, from the start to measure, everything should be completed within that coherent time. We should not risk having the depth of the circuit go beyond the decoherence or go beyond the coherence time. So it is necessary to optimize your circuit such that it is completing within coherence time. The coherent time should be met out before solving your solution. So optimization of quantum circuits can be done by a machine learning model. So that is the connection. Then we can extend this capability to other domains. Do you remember when you fly in the flight, the first notice, if something happens, put mask to you first, then help others? The same way, the machine learning and then quantum AI first help quantum circuits. After that, it will go to other domains. So that is one thing I am seeing now.
That was one of the most clear explanations in terms of where quantum AI actually stands right now. So thank you for that. Thank you for clearing that out. Taking that a
Thank you.
step further, however, there have been recently a friend shared to me this article about something that a particular AI model was able to. It was blackmailing a developer because the developer was trying to change it. Now I did not go into the details of it, but there the question of emotional resonance came up. It might not be in the same sense as we humans think about emotions or perceive them, but in again terms of competition, where we are at a stage where we are at least trying to build intelligence, mimic it or build it, whatever may be more apt. What exactly is the mechanism for a system, artificial intelligence, classical based or a quantum based, to develop something close to an emotional resonance, a pattern of mutual state of resemblance or analysis of patterns of or response to human emotions, that it may try to mimic or gather some details on how to act? How do you think that particular forte in this entire discussion is bound to evolve?
Okay. The emotional part, it is subjective. It is subjective. Anything subjective cannot be mathematically represented. That is the first my understanding. Subjective means when mm, you are see, we are in the podcast of we are released it, someone watching this podcast putting one comment, my understanding or my emotion after reading the comment is entirely different from your emotion, but the comment is same, but the emotion are different depending on the time of reading that comment. You got the point, right? So the emotion part is subjective in nature, so it cannot be attached to any mathematical process or any mathematical object. So that is one thing I want to very clear about that one. When you say emotion, the level of emotion, understanding the emotion is different. For example, when you say just now you told, right, there is some AI model which is blackmailing the developer, right? That emotion, the word blackmailing may be the first emotion of the developer, but even for the same developer, after one day, that may not be blackmailing, it may be restrictive. After one week, it may be, it is guiding. So the emotion from blackmailing to restricted to guiding, it is changing, subjective to the person, time, situation, everything. So when you are trying to build something emotional content or emotional aspect with a system which is cannot be represented at all, we cannot achieve that emotional part. I'm very clear in this one. As till we are the human finding a mathematical object which is subjective to the different thing, we cannot achieve emotional part. As of now, there is no any mathematical object which is subjective depending on various parameters. So to my knowledge, emotional capabilities or understanding the emotional part to machine is not in the purview now. Maybe this may be a strong statement because there are researchers working on bringing emotion to the machine intelligence. But as a person who studied applied mathematics and applied statistics, and throughout my career, used that applied mathematics knowledge. I will continue use that one. I am having a clear understanding that trying to build an emotional part or emotional capability using these machines futile. We cannot expect. That is my understanding. But still, you want to know, KG? No, no, no. There should be some way. Can you give some idea? I will tell you one aspect. If assume that a quantum circuits, you build 5 qubit quantum circuit, and you are making all the 5 qubits into superposition, and you are applying some quantum gates. What is happening now? The the quantum circuit is creating a Hilbert space, and that Hilbert space can be represented with a density matrix, right? So if you have n qubit, 2 power n times 2 power n, that is the density matrix size. It is not n by n. That is very clear. So you have n qubit, your density matrix will be 2 power n times 2 power n. Very big density matrix. It is having 2 power n axis dimensions. And if a person try to read the value from one angle, it will give some meaning. If a person read from another angle, it will give different meaning. You can consider this as the subjective nature of emotion. But still, the direction from which you are going to measure, that is your choice, or the mathematical object choice.
A sort of pattern of mutual state collapse depending upon the you know interactors perspective. So they may up to them it may appear to resemble a particular emotional state that is sort of representative of their particular understanding of emotions, something like that, right?
Exactly.
Right. And even maybe an oversimplified analysis from my side, but the current, maybe the generative AI models and everything, they, a very simplistic definition of emotional sort of quotient to them is generally how they mimic the user's sort of lingo, or the behavioral patterns, the linguistic patterns or the semantic patterns that they are able to derive. They sort of customize their responses based upon that. Something like, if I'm of a particular personality and you are of a particular personality, You use chat gpt on a daily basis for x hours, I use chat gpt on a daily basis for x hours. By the end of a particular time frame, let's say 30 days, if we take both our models and we ask them the same question, the in general way in which they answer will be different, which will give a perception to us that they both have got different personalities. But that difference isn't a reflection of their emotional state or emotional quotient or capability. It's a reflection of their respective users states of or behavioral patterns or whatever. Like all that data isn't individualized to those models, but rather to the users, to us, you and I. And maybe that is one aspect of how this plays out in the current diaspora. Could it be something?
Here I would like, see, your understanding is correct from the person who are experiencing gen AI tools as a end user, right? But as a person who is able to build a gen AI tool, you got the difference, right? Assume that you are the consumer of gen AI tool, but I am the producer of gen AI tool. I can build my own gen AI tool. So obviously I know the aspect of transformer, attention, network, all those things, what is powering the GPTs, I know very well. So when you say that after 1 month, ChatGPT will give different response to our prompt based on our 1 month history, I can mathematically connect it. It is just the parameters in the transformer which is adding your lingo to your answer and my lingo my answer. It is nothing but tokens, because it's collected based on my interaction. It's collected lot of tokens and then it is forming the token, and on top of that OpenAI puts some level of guidelines for the parameters. See, all the answers should start with um, maybe 0.5 percentage of positive words, and it should end with 0.75 percentage of positive words. It should be sandwiched in between your answer. And if OpenAI is able to change, increase the positive words in the beginning to 1 percentage, you will see two sentences which is pricing your question. You got the point, right?
Yeah, yeah, yeah,
So
yeah, yeah.
the emotion is just parametric change by the model. So for me, being a person who can able to build a Gen AI tool, it is not emotion. It is just a transformer dealing with the tokens.
Just the back end hyperparameter tuning working on the different nodes. Nothing more than that. Yeah. Hmm.
Yeah.
Hmm. Hmm.
So you also from the background you are able to understand easily. But a person without any software knowledge, without any mathematics, an end user, assume that a housewife is using ChatGPT for their day-to-day work. They were surprised. Oh my god, this ChatGPT is my best friend. You got the point, right?
Yeah, yeah, yeah. 100%. Absolutely.
Yes.
And okay, so there is this final segment that we do on the show. So, KG, what would be your word to humanity at large? Any message that you have for the entirety of humanity at large?
Love.
It's sufficing. It is sufficing.
That is the only thing which makes the human survive, sustain, and excel. If that one element is missing, we are nothing.
True. True. Thank you so very much for agreeing to do this conversation and then just having this entire absolutely delightful conversation that we had. Thank you so very much.
Thanks a lot for this opportunity. Your questions are amazing, and that is, I really appreciate your depth of knowledge. Otherwise, these questions will not come. And I realize that you have the potential to be successful in quantum industry or whatever industry you are
Thank you.
pursuing. All the best.
Thank
Thank you.
you. Thank you.